Suppose you suspected that you had a rare disease. This hypothetical disease only affects 1 in 10,000 people. You go to a doctor who gives you a test which gives the correct diagnosis 99% of the time. That is to say, that if you have the disease, it will tell you correctly that you do, 99 times out of 100. And if you don't have the disease, it will tell you correctly that you don't, 99 times out of 100. You take the test, and it comes back positive, saying that you do in fact have the disease. What is the likelihood, what is the probability, that you have the disease, given this information? Instinctively, you might think, well, it's obvious. I'm 99% likely to have the disease. But actually, you're less than 1% likely to. Sounds ridiculous, I know. Let me prove it to you. Suppose we took 1 million people from the population. Because this disease affects 1 in 10,000 people, 100 people will have the disease, and 999,900 people will not. And let's say we gave this test to everybody. Out of the 100 people who genuinely have the disease, 99 of them will receive a correct, positive result, saying that they do in fact have it. But because the test is only correct 99% of the time, one of these 100 people will be told incorrectly that they do not in fact have the disease. All makes sense, no surprises so far. Now let's consider the people who don't have the disease. 99% of them will be told correctly that they do not in fact have the disease, and that works out to 989,901 people. But of course, 1% of this group will receive an incorrect, positive result, and that comes out to 9,999 people, which is far more than the 99 people who received a correct positive result. It's far more likely that you're in the group that was misdiagnosed. The probability that you actually have the disease is 99 divided by the sum of these two numbers, which works out to be 0.98%. Now, of course, this is a simplified example. In the real world, a doctor is going to be factoring in a lot more information to arrive at a diagnosis. Not only that, tests will often have very different false positive compared with false negative rates, meaning that it will diagnose people who don't have the disease incorrectly at a very different rate than it will diagnose people who do have the disease incorrectly. The reason why I like this example is because it's a tangible demonstration of how counterintuitive statistics is for people who haven't studied it, and how we naturally ignore information which might be really important for arriving at a logical conclusion.